The Gaia Space Telescope has measured the acceleration of the Solar System when it orbits the center of our Milky Way galaxy. The Solar System motion relative to the stars agrees with the results by Finnish astronomers in the 19th century. Moreover, the observational data by Gaia improves satellite navigation. Finnish researchers are participating in this massive endeavor that results in three-dimensional mapping of our galaxy, to be completed in 2024. Today, December 3, 2020, the European Space Agency, ESA, released observational data from the Gaia telescope, Gaia Early Data Release 3 or EDR3, in continuation to the DR1 and DR2 releases of the years 2016 and 2018. Gaia accrues accurate knowledge about, for example, the Milky Way stars, distant extragalactic quasars, and the asteroids of our Solar System. Quasars are bright, star-like objects that allow for the determination of planet Earth's orientation in space. With the help of their precise positions measured by Gaia, a new high-precision reference system can be constructed for defining the positions of stars, Solar System objects, and also satellites. The knowledge accrued by Gaia affects the precision of satellite navigation in the future. The satellite positions and Earth orientation in space are determined in a reference frame tied to the directions of quasars. The precision and state-of-the-art of the reference frame are critical for the precision in navigation, says Professor Markku Putanen at the Finnish Geospatial Research Institute FGI, National Land Survey of Finland. The precise observations of quasars resulted, for the first time, in a successful computation of the acceleration of the Solar System. The acceleration of the Solar System towards the center of the Milky Way, as measured by Gaia, is 2.32 plus or minus 0.16 x 10 to 10 meters per square second, or roughly 2/100 billionth parts of the gravitational acceleration caused by the Earth on its surface, summarizes astronomy professor Kari Muinonen at the DEP. Gaia in the research of asteroids. Gaia's data processing is carried out within the European DPAC network, Data Processing and Analysis Consortium, with more than 300 researchers. Solar System researchers at the University of Helsinki take part in the Gaia data processing in several different ways. We are responsible for the daily computation of orbits for asteroids discovered by Gaia. Based on these computations, ground-based follow-up observations are organized, describes Muinonen. Before data releases, we take part in the validation of Gaia observations of asteroid positions, brightnesses, and spectra. Our research with Gaia data focuses on asteroid orbits, rotation periods and pole orientations, masses, shapes, and surface structural and compositional properties. In the computation of collision probabilities for near-Earth asteroids, the precision of reference frames is completely central, continues Muinonen. Asteroid observations by Gaia were published in DR2 in spring 2018, 14,099 asteroids. In the forthcoming DR3 release in spring 2022, there will be position and brightness data for tens of thousands of asteroids and, for the first time, asteroid spectra will also be released. Years of work and billions of stars. The EDR3 data has been collected by Gaia from the end of July 2014. The data includes, for example, position and brightness data of 1.81 billion stars and color data of 1.55 billion stars from the time period of 34 months. Furthermore, the data more than triples the number of quasars observed for precise reference frames to 1.61 million. EDR3 is a remarkable improvement, in terms of both numbers and precisions, as compared to the earlier releases. The newest release gives hints about the gigantic nature of the forthcoming DR3 release in spring 2022 and the final DR4 release after 2024. Gaia observes astronomical objects systematically in the so-called L2 Lagrange point some 1.5 million kilometers from the Earth in the anti-Sun direction. Gaia observes about 2 billion stars with a precision, at best, of 100 millionths of a degree. The result will be a three-dimensional map of our galaxy. Stellar motion in the future based on the Gaia data. Researchers have modeled the motion of stars in the Milky Way. They have produced an animation for the motion of 40,000 randomly selected stars on the sky 1.6 million years into the future. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.